GM, what's up, clubbers? In today's video, what we're going to understand is what are soul-bound or account-bound tokens, how do we leverage them, how do we create them, what are the differences between them and NFTs and tokens and whatnot, and a few reasons why somebody would want to issue or collect them. But before we get started, please make sure to hit that like button, subscribe to this channel if you're new here. If you want to send me any message, please leave it in the YouTube comments. And if you have a specific question, come join my Discord server. There are a bunch of people just like you and me who are trying to help each other out. Very soon, I'm also going to launch a small job board so that anybody who's looking for a job or advertising a job or a bounty can just upload there and our community can have fun with it. Alright, with that said, let's get started. So firstly, what is a soul-bound token? A soul-bound token or an account-bound token is a token which is attached to your specific address. You cannot transfer it. The only thing that you can do is revoke that token or give it back to the person who has issued it or the account who has issued it. But if you cannot transfer or sell that token, what good is it for you? Like, how will you make some profit out of it? It's not always about profits. There are few reasons why you would want to have or issue a soul-bound token. The first thing is that it acts as a verification which was done off-chain. This can be for something like a college degree or a job experience. Let's say you're a university and you want to issue a certificate to a specific student. So once they graduate, you ask them for their address, and what you do is go onto the blockchain and issue a soul-bound token to their specific address. This way, their degree sort of follows them everywhere they go. Of course, they have the option to revoke the degree, and the college has the option to take it back or revoke again, right? Same thing with a job experience. A user can work with me and I can issue a certificate for them on the chain, which they cannot transfer, they can only revoke. Also, transferability is not a desired outcome for every sort of token. For example, you played, let's say, an esports tournament and you won. Now, what we do is we issue a trophy to your account, but you cannot sell that trophy. Why? Because that trophy stands as proof that you are the winner and that you, that person itself, should get future benefits from holding that trophy. If that trophy is transferred to somebody else, they should not get that benefit. So that is why we don't need transferability in every sort of token that is present out there. Another thing is reputation. Let's say I am an independent jury and I discover what is your credit rating and I put it on chain. Now I don't want you to transfer that credit rating to somebody else. I want you to basically be the owner of that rating. And for those kind of situations, soul-bound tokens or account-bound tokens are a much better solution than, let's say, an NFT. But how do you as a user profit from even holding a soul-bound token? Why would you even want that? You can, of course, sell your NFTs, but you can't sell your reputation, your soul-bound tokens. How will you ever profit from this except for the fact that, you will get some access to some places? Well, the simple answer is airdrops. You will sort of receive some airdrops based on, let's say, winning a trophy, having a certain reputation, having a verified on-chain experience or something like that. Let's say I want to give an airdrop of XYZ token to all the Premier League winners. What I'll do is I'll figure out who are the players which have these tokens and I'll send an airdrop their way. Vitalik has a good post around soul-bound tokens, which I think you should read and understand if you want to go in depth. Now, while researching for this video, I couldn't find a lot of EIPs except this one, which is an account-bound token EIP. And it is still not finalized, it's still in the draft stage, but I mean, this is something that we can still go ahead and look and use in our today's video. One thing, of course, that you can do is create an NFT which cannot be transferred except back to the 0th address or just burnt. The code for that would be very simple. Just create an NFT which only owner can mint and send it to somebody else, and only the owner or the holder can burn. And there in before transfer token, just throw an error so that the user cannot transfer that token anywhere else except burning it. If you want to create an NFT which cannot be transferred, just let me know in the YouTube comments so that I will create either a video or a post explaining how that works and also attach code to that. Alright, so if you go through the EIP-4973, which is for account-bound tokens or soul-bound tokens, you can just read through it. It's not a very big EIP, it's a very small EIP. But the biggest thing, the specification that we want to understand right now is this: the interface EIP-4973. This interface has four things: two events, two functions. So the first event is a test. This event is emitted when a new token is created and bounded to a specific account. The second event is revoke, which is the opposite of a test, which means it is emitted when the token is removed. There's a function called owner of, which returns the owner of a specific token ID. And the fourth is the burn function, which basically revokes a specific token ID. For the metadata for these specific account bound tokens, we will refer to the ERC-721 metadata interface. So if you just read the rationale over here, they are basically saying that we will use ERC-721 metadata interface so that the account bound tokens or the soul bound tokens are maximally compatible with the current tools which are used to showcase NFTs. And the EIP also has a standard implementation for EIP-4973, which you can find over here. Now I've downloaded that specific example implementation, and this is what the code looks like. So it expects us to give an ERC-165 contract, an interface for the 721 metadata, and the interface for 4973, which we just saw. So what I'm going to do is just copy this whole file and paste it in Remix. So I have Remix open, and what I'm going to do is create a new file and call EIP-4973.sol. Alright, and I will paste the file over here. Now there will be a bunch of errors as you can see with the one over here. Let me just increase the font size. Hopefully this is much better. Now there are errors over here because we don't have this ERC-165 file present, right? So what I'm going to do is create this file again, ERC-165.sol. And I'm going to open the OpenZeppelin contracts. So on the OpenZeppelin contracts repository, go to contracts, utils, introspection, and then ERC-165.sol. So now that we have ERC-165, what I need to do is I need to copy this whole line, and then in the remix just put this here with the import statement and put this in strings, and over here just write @ and then slash. So it should be OpenZeppelin/contracts/ contracts, we need just one, /contracts/utils/introspection /165.sol, ERC-165.sol. So now if you go back to the errors, you will see that it says that the contract interface IERC-4973.sol was not found. So that again we have a simple fix. Just create a new file called IERC-4973.sol, and what we need is we need to go back to our EIP and just copy this interface. So paste it over here. You will see that the interface is present, and then what we do is we go back to the original file and remove interfaces from here. And the next thing that we need is IERC-721 metadata. To do that, we go back here, we create a new file called IERC-721 metadata.sol, and I go back to the OpenZeppelin contracts, go to tokens 721 extensions, and then I just need to find this IERC-721 metadata.sol. Now I just need to copy the whole file, paste it over here. The only thing that we need to do now is remove this importing of the whole 721 interface and just leave it as it is. So we just need the IERC-721 metadata interface. We don't need the whole 721 interface. And then we go back to the 4973 file and remove the interfaces bit from here. Now this should solve all the errors that were present. But again, this is an abstract file. This is not the final contract. So what I will do is create a new contract called abt.sol. And now in abt.sol, first, of course, we need the SPDX license identifier, and then we need the pragma solidity line. Then we do contract ABT and then just create a simple contract. Now, of course, the next thing that we need to do is import the EIP-4973.sol. So we have imported the EIP-4973.sol, and now we need to write ABT is ERC-4973. Now why ERC? Because by mistake what I've done is I've written the file name as EIP-4973, but the contract name is ERC-4973. Alright. So now this will give us an error which says, firstly, the constructor is missing, and secondly, we haven't implemented the function called burn. So let's create the constructor first. The constructor will be an ERC-4973. And it takes two arguments. First is the name, which will be my token, and second is the symbol, which will be mtk, and the constructor, let it be empty for now. And the second thing that we need to create is function burn with un256 underscore token id. The function needs to be external and it is an overridden function, so we need to write override over there, and here we just call underscore burn with underscore token id as the parameter. So this is a very simple account bound token. Anybody can issue this, anybody can revoke this. There are no permissions or anything like that. So of course what now we can do is import the ownable module and use that to make sure only the owner can burn and issue these tokens. But instead of importing, what I'm going to do is just write that ownable module over here, so that it's just much more fun. So the address will be public, which will be of owner, and the owner will be set in the constructor itself, who and will be the person who has created this contract. And then what we're going to do is create a modifier called only owner. Owner, and which requires that message.sender is the owner, or we throw an error called not the owner, or otherwise if it is the owner, we just move forward. Now that we have the modifier, we just need to put it over here that only the owner can burn this token. Now another thing is that there is no way to actually issue this token as of now. So what we're going to do is create a new function called issue, and what this issue will do is issue a token to a specific address. And this issue function also accepts a URI where we have stored the metadata for this token. This can be something like the address of issuee, and then we need to write string call data and then underscore URI. Now this can be called only by owner, and this is also an external function, and this internally calls mint, and you can check out what the mint function looks like. It takes a token ID and the URI. All right, so this function basically calls mint for the issuee with the token ID, which I will compute in a minute, but let me just put like nothing over there, and then underscore URI. Now there are a bunch of ways you can compute the token ID. You can have it sequentially increased. You can make sure that the person who is sending this URI knows what they're doing, stuff like that. What I'm going to do is going to do a very simple increment for the token ID. We can have a UN256 which can be public and store the count, which can start from 0, and we can have count over here, and then the count will increase by 1. This is how you issue a specific SBT or ABT or whatever, and this is how you burn it. Now the problem is only the owner can burn it. What if I as a receiver want to burn it? So what you can do is, instead of this, what you can do is just write require the owner of underscore token ID is the message.sender, or message.sender is the owner. Otherwise you can't revoke this token. Alright, so now this is a fully functioning ABT or SBT, soulbound token or account bound token, whatever you want to call it. You can of course go ahead and test this out. So just select the ABT over here and deploy it. Once deployed, you can see these are the few methods that are available. There's a name, there is a symbol, there's a token URI, so every token will have its own URI. There's a burn, and there is an issue. So only the owner can issue a token. So let's say I want to issue a token to this specific address. So what I'll do is I'll just paste the address and the URI will be, let's say, URI. Okay. So if I click transact, the transaction succeeds. But if I try to send this transaction from somebody else, the transaction fails. Alright, this is exactly what we want. And you can check the token URI for the zeroth element, not the element, but the zeroth token ID. And the value that shows up over here is URI. It is very small to read, but I mean, you can verify it yourself. You can see the owner is me. If I would have used the ownable module, I would have gotten the access to revoke my ownership, transfer my ownership and whatnot. But I haven't. I chose to implement it myself, so I don't have those. And then count, you can see, is increased to 1. Another thing that we can try is that you cannot burn a token if you don't hold it or you're not the owner. So if I press the token ID 0 to burn, the transaction reverts. You can check who is the owner of this token ID, which is the 0x4b2, which is, I believe, the third account. So I can select the third account and try to burn the token. The transaction succeeds. Now I want to issue one more token from the owner to the same account, and the transaction should succeed now with the owner of 1 being the same address that we had sent. Now even from the owner itself, what we can do is click on burn for the first token ID, and the transaction succeeds. The burning is successful. Now if this was deployed on a test net, on the main net, I believe OpenSea should have sort of read this, but I'm not 100% certain whether OpenSea reads it or not. Once I tried on the test net, it did not. But then again, OpenSea is not working well with the test nets for a very long time, so I don't know what to trust. So this is how you create an account bound or a soul bound token, and this is how you issue and revoke those account bound tokens. Metadata module helps you to display that account bound token, and the other aggregators, the NFT aggregators like OpenSea or your wallet, they generally have methods to use that metadata module to actually show these tokens. You can also implement a simple NFT where you cannot transfer the NFT. The only thing that you are allowed to do is burn, and it is issued by only the owner, or they can also revoke this NFT. If you like this video, please make sure to hit that like button and subscribe to this channel if you're new here. If you want to send me a message, please leave it in the YouTube comments down below, or if you have a specific question, come join my Discord server. There are a bunch of people just like you and me who are trying to help each other out. I'm also trying to create a job board of sorts so that the community as a whole can talk to each other, discuss jobs and everything. I hope to put it up in the next month or so. So fingers crossed. Thank you so much for watching the video. I hope to see you again next week. Till then, bye.